Hello and welcome to another tutorial. So in this tutorial, we're going to be looking at custom serialization within Unity. So what I'm meaning by that is being able to do something where we set up our own custom type, but we make it so that it can be shown in the inspector and so that we can actually have those inspector settings be actually changing things. So there'll be a little bit of custom editor side things that we'll be setting up as well for that. So let's dive on in. So the context for this and sort of where you might want to be making use of something like this, there's a couple of scenarios. So one of the big ones that I've used this for and was in terms of what we're going to be creating today is something called a serializable type. So in Unity, we can, and this is part of what's available in the C# language, there is a variable type called System.Type. And everything that exists, you can get a System.Type that represents the type of that, which you can then use to construct things, find stuff, all different things like that. Really handy and really useful. But the Unity inspector doesn't support working with that. So if I wanted to do something where in the scenario that this came up for me was, okay, I want to be able to have a drop down that lists all of the particular types of classes. Now I could do a custom inspector for that particular use case, but I wanted to do something more generic that I could use in a lot of different scenarios. So that's what we're going to be creating here. So I'm going to create a folder. Right. So, okay, let's get this set up. So first thing I'm going to do is I'm going to have our actual serializable type class. Let's make sure I get my spelling right. Serializable type. And then I need the editable or editor side support for this. So what I'm going to do is I'm going to create a folder called editor. So we have to do this when we've got scripts that are editor only. They do need to be in their own specific folder. So this one is going to be serializable type property, well actually I'll call it drawer. And I'm going to put UIE there because this is going via UI elements for doing this. So, okay, let's get this set up. So as I said, what I want to be able to do with this is I want something that can essentially wrap around a System.Type that we can use for actually easily sort of serializing that and being able to display that in the inspector. So I want this to firstly not be a mono behavior, but it's going to implement a couple of interfaces. One of those is going to be this serialization callback receiver. That's one Unity provides to allow us to actually save and load stuff. The other thing is I'm going to implement system.IEquatable. Now, the final thing I'm going to change here is I'm also going to make this a generic. So we're kind of going all in on a few different things with this in terms of bits that we are adding into this. It's going to be quite a few little things we need to get up and running. We also need to mark this as system serializable. So a couple of things we do. First thing is I need to have, and I'm doing this attribute, field system.nonSerialized, because what I want to have is a public System.Type, publicly gettable, privately settable, defaulted to null. So I'm being very explicit that I don't want it to be serialized, and this also allows it just to be publicly accessible, which is really handy. I'm then going to have, and this is the field that Unity will automatically serialize. And I'm also going to hide it in the inspector. And this is our assembly qualified name. Because different types can exist in what's called different assemblies. So the actual full name for a type, we need this thing called an assembly qualified name. So, okay, Unity will automatically save and load this because we've marked it as serialized field. But what we need to do is kind of interject ourselves into that save and load process to actually populate this type. And that's where this serialization callback receiver comes in. So what I'm going to do is implement that. So, okay, in terms of where these actually run, so our on before serialize, that runs before we actually go and save. So on before serialize, what we want to be doing here is from our type, generate our assembly qualified name. So what we would do is, okay, well, assembly qualified name is equal to, if type is equal to null, then it's going to be null. Otherwise, we use the assembly qualified name. So this happens before we actually save it out. So I'm going to put a note in here because it's easy to get confused. Saves this object out. So it runs before it. So this one then runs after Unity has loaded it. So note, this runs after Unity loads the object. So this one has to kind of do the reverse. So this one is populating type. So if the string is null or empty for the assembly qualified name, then we default that to null. Otherwise, we can do a System.Type and we can get the type using that assembly qualified name. That's pretty straightforward, and that's actually covers all of the serialization side. And this is something where this process that I'm using here, I could use this same process for doing something like my own, a version of a dictionary that could be serialized, or any sort of complex type where Unity might not inherently support serializing things, because Unity supports our basic types, our enums, our numbers, strings, supports lists of those things, but it doesn't support stuff like dictionaries. And so if we have dictionaries or we have classes that contain other things it doesn't serialize, then this gives us a way of actually managing that process. Also lets us have it potentially serialize a very compressed version of stuff, a very optimized version. So we've packed that, and then we can do a unpacked version. So different options that we've got there with this. So I want to have this implement the equatable interface. What I'm going to do is initially remove that. I just mostly had that there as a reminder for myself, because what I can do is I want to actually generate the equals and get hash code. We don't want to include type, so that's good. And in terms of with this, there's not really any other actual modifications we need to do with this. It's completely fine the way that it is. So, okay, that gives us something that is a serializable type. Let's see about how we would use that. So, serializable type test script. Okay, we're going to create an empty game object that we attach this onto. And then what I'm going to do is I'm going to have a public serializable type, and we might go for, let's pick something straightforward for this. I'm going to create a couple of demonstration classes here. Demo base of demo child 1. And let's also have demo child 2. I might make that parent one there abstract, like that. That's good. So I want to be able to serialize a demo base. Default that like that. Let's also test, really stress it and create a list like that. Let's initially see what that looks like in the inspector. So you can see it's got the list there, but none of the entries, none of those bits are actually working. And that's to be expected. That's because it doesn't really know how to actually draw this particular sort of property and everything. So we kind of need to provide custom logic for it, which we actually want to anyway, because we've got set up with the actual, it being a generic. So we want to be able to be doing specific logic there for that. So I'm going to get rid of this. What I'm going to do is this is actually a property drawer. I need to say that it's a custom property drawer. The type of is a serializable type, like that. And we provide true because I want to use this for any child class as well. So I'm going to implement this working via UI elements. So because I'm supporting UI elements, what I do is I do a public override visual element create property GUI, like that. So good so far. So UI elements, that side of things for doing inspectors is in a really solid place. So it's what I would generally recommend using these days. Works a little bit differently, but really handy. So, okay, what I'm going to do is I want to populate here a System.Type supported types, because I actually want to show for this a drop-down, and it just shows only the types that are valid to select there. So what I need to do, and this is a bit of a weird process, we're having to kind of go a little bit lower level with stuff that happens in C#. So we have our boxed value type. So we get that by, I'm going to rename this to follow my conventions. So in property, boxed value, get type. So boxing in C# has a very specific meaning, and you might see at times references to boxing and unboxing types. So there is a bit of an overhead of going through those processes of boxing and unboxing, but it's something that's unavoidable in this case. So what then want to do, okay, we've got our boxed value type. We want to then actually get our specific filter type, because the boxed value type will be our generic. So that will actually be a serializable type of T. We want to get what T is. So our filter type, we go boxed value type, we go get generic arguments, and we access the first one. That's going to give us our filter one that we need. So then we find all of the matching child types. So we're going to loop over every assembly in our, and we get the app domain, oops, not app context, app domain, current domain, get assemblies, because our project is going to be comprised of multiple assemblies. This lets us retrieve all of them. So then we loop through every type in the assembly. Just put that as type. And then what we need to check is, okay, if that type is a subclass of our filter type, and it's not abstract. Because we don't want to actually be picking something that's an abstract type. Then we add that in. Now, some important sort of things with this. This is editor-only code. You know, there's obviously a lot of stuff that's very specific to the editor there. The thing I would add is these processes here where we're traversing assemblies, things like that, those, if you're having a case where you might want to be trying to do something like that in a build, you can run into issues with that. So that is something to be mindful of, that while this code does work in an editor, in a build, you can't make those same assumptions. So then we want to sort our types. So we're going to just go supported types, sort. We'll set up our own little helper for that. And all we want to do is just go LHS name, compare it to that. That's just going to put them into alphabetical order. Then we can start to set up our actual UI. We can build that. So we have a property container, and that's a new visual element. Then what we need to do is we need to check, okay, do we already have this in our container? So, okay, cool, is in container. So what we check is, okay, well, System.Type get type in property display name. So if that's not equal to null, then that means we don't have a valid one already selected. So then we set up our type selector. So this is where we're populating all of the possible options into the list. So, okay, our type selector is a new drop-down field. If the thing is already in the container, then we go for that being empty. Otherwise, we use the display name. Then we loop through our supported types. So I'm going to manually add in a particular choice. And the thing I want to add in is an option to be able to select none, because that's handy to have. Then all this needs to do is we add in the actual name of the type. So that's good. That gives us everything populated for our drop-down. We want to attempt to select the current one. So attempt to select our current type. So we're going to grab a serialized property name prop, and we go in property, we try to find property relative, and we're looking for assembly qualified name. This has to match our variable here. So if you run into issues, just make sure that those match exactly. The case, all of it has to match precisely for it. So, okay, F, and we check string null or empty, and we look at that string value of it. If that's the case, then type selector, the active index is 0, which will be our none entry. Otherwise, what we need to do is find the entry. Check if it's been found. We assume that we've failed to find it by default. Then we loop through our types. It has to be less than the supported count, like that. And what we do is we check, okay, well, if supported types at that index, and if its assembly qualified name matches that string value, then we know we've found it. So found becomes true. We will break. The other thing that I will do there is, okay, type selector index is set to that. What I do at the end is if it didn't select anything, then I just go, okay, type selector index is 0. The only reason I'm not just sort of doing this automatically by default is just because sometimes things like that can result in unintentional selection when you haven't meant it to. So I'm only setting, I'm making sure that the type selector index is always going to be populated, but I'm just ensuring that there's a bit of, it's only ever set once. I'm not accidentally setting it multiple times. So what I then want to do is handle that selection actually changing. So handle selection changing. So what I do is my type selector, I go register, and I register the value changed callback. What I do is I have fallback data. This, and what I'm going to do is nameProp.string value. So if the type selector index is 0, then we've selected none, or nothing was able to be selected. So I'm going to have an empty string. Otherwise, I want to go supported types, type selector index, and I subtract 1 from this. Then what I do is grab the assembly qualified name. So the reason I'm subtracting 1 from this is because the first entry is none, and the actual type entries are afterwards. Also means here, when I'm setting this index, I should have a +1. Otherwise, we'd have everything offset slightly, which would be incorrect. Then what I need to do is the name property, serialized object, I tell it to apply the modifications. My property container, I add my type selector, and then I return my property container, like that. So if I save that, then what I should find is I can actually make use of that now. So I go to my game object, can see we have the drop down appear, and I can see, I can select it to demo child 1. To properly test it, you want to kind of select it and select away. We make sure that we can pick each of the individual options and that they function, which that's working. Our list entry here, let's make sure that behaves. Again, we go away from it, we come back to it. The only thing you do run into is this at a little bit with the formatting, but otherwise it works fine in a list. So that's good. And the reason it does that is because the text is empty. So we could likely do a little bit of a fix for that, but that's just down to it being empty. But that's actually, I kind of don't really mind it because it makes it easy to see when you've got a none entry there. But that works. And what I could do, just to test this out a bit, set that to that. I'm going to firstly save all of this. And then in my test script here, what I do is debug.log demo selection type. And then for each entry in demo selection list, I'm going to do a debug log of entry.type, same sort of thing. So let's see how that works. We should see it matching the outputs there. So we get demo child 1, 2, and then null, which exactly matches the set of entries that we have got there. So that's good. So we now have a system for being able to serialize these types, and we've hooked into the serialization process there in Unity. So we've also got a good example of both, how to actually do the custom serialization, but also for when we then want to customize the inspector and adjust how that's being drawn, and in particular doing that via using UI elements for this. So this gives us sort of a good basis for if you did want to do this for your own custom types or set up your own support for custom dictionary, things like that. All of those are ones that could be done via modifications to this method. So dive on in with this and experiment. See what kind of things you can do with this, see where you might have use cases for it in your own projects. Thanks, folks. If you found the video interesting and helpful, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, it is available up on GitHub. Then there is a link to that in the description below. You can use that code in any of your own projects, commercial or non-commercial ones. If you've got any questions or other things you'd like to see, chuck those in a comment below. And if you're looking for other ways to support the channel, I do also have a Patreon, and there is a link to that in the description as well. But until next time, bye.